Class section 8.2 and 8.3 are all about the quadratic formula and the discriminant. Solutions of the quadratic equation in standard form with a not equal to 0 are given by our quadratic formula, which you will have to memorize, but it's a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can use this to factor trinomials, especially ones that are prime. And it makes life a lot simpler. But sometimes our old way was simpler. So I'm going to show you how to factor our old way and using the quadratic formula. So first let's do the old way. So I have x squared plus, sorry, that's supposed to be a minus, otherwise it won't work. So I have x squared minus 5x plus 6 equals 0. So I find the factors of AC that add up to b, and those factors are when x is negative 2 and negative 3. So I get x squared minus 2x minus 3x plus 6 equals 0. And then I'd factor by grouping. I get x times x minus 2, negative 3 times x minus 2 equals 0. So I get x equals negative 3, sorry, I have x minus 3 and x minus 2 equals 0. And I set each of these factors equal to 0. And I find that x equals 3 and x equals 2. Now, I did go ahead and factor by grouping, even though I could have already skipped to this step because a equals 1. But I wanted to show you one more time how to factor by grouping. Now let's use the quadratic formula. So I always want to start by labeling our A, B, C's. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 5 plus or minus the square root of 25 minus 4 times 6, which is 24 over 2. So x equals 5 plus or minus the square root of 1 over 2. So x equals 5 plus or minus 1 over 2. So x equals 5 plus 1 divided by 2, or x equals 5 minus 1 divided by 2. So x equals 3 and x equals 2. Woo! That was a lot of math. So sometimes it's easier to factor our old way. On the exam, I will specifically ask you to factor one problem by finding the factors of AC that add up to b, a second problem by completing the square, and a third problem you have to use the quadratic formula. After that, on every exam, I don't care how you factor as long as you factor properly. All right, so let's go ahead and factor some equations using the quadratic formula. Here I have a equals 6, b equals negative 5, and c equals negative 4. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times 6 times negative 4 all over 2 times 6. So x is negative 5 plus or minus, got a 12 down here. I've got the square root of 25 plus 4 times 6, which is 96. So x equals negative 5 plus or minus the square root of 121 over 12. Well, the square root of 121 is 11. So x equals negative 5 plus 11 divided by 2, or x equals negative 5 minus 11 divided by, not 2, 12. this was a negative 5. So that gives me x equals negative 5 plus 11, that's 6 twelfths, so 1/2. And x equals negative 5 minus 11, so x equals negative 16 divided by 12. That's x equals negative 4/3. And this should have been negative, so my signs would have been different on my solutions. But we saw how the quadratic formula worked. So now I have 4x squared equals 8x minus 1, which I would copy correctly. 4x squared equals 8x minus 1. The first thing I need to do is, ooh, I got an email. The first thing I need to do is get this equal to 0. So I'm going to subtract 8x from both sides and add 1 to both sides. So I have 4x squared minus 8x plus 1 equals 0. I then want to label my A, B, C's. A is 4, B is negative 8, C is 1. So x equals plus negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals a negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 all over 2 times 4. So x equals 8 plus or minus the square root of 64 minus 16 all over 8. So x equals 8 plus or minus the square root of 48 all over 8. But I can simplify this radical, square root of 48. 48 factors into a 4 and a 12, which gives us a 4 and a 3, 2, 2, 2, 2. So there are two sets of squares in 48. So I could rewrite 48 as 2 squared times 2 squared times 3. If I take the square root of 2 squared times 2 squared times 3, remembering that square roots cancel out squares, and I could break it apart like so, I'm left with 2 times 2 the square root of 3, so 4 square root of 3. So x equals 8 plus or minus the square root 4 square root of 3 over 8, which I could simplify because all of these have a factor of 4. So I have 1 plus 1/2 square root of 3 plus or minus square root of 3. So x equals 1 plus 1/2 square root of 3, and x equals 1 minus 1/2 square root of 3. Now, if you aren't quite sure what I did factoring and simplifying this radical, please let me know, and I can include a link to one of the videos I've made on that. Maybe I'll even remember to put it in the comments. Also, leave things in irrational form. Do not type into your calculator and round. These are irrational numbers. Their decimal places go on forever, so it's not the same when you round it. You aren't as accurate as you are if you were to leave it as the square root of 3 or the square root of 2. Last but certainly not least, I have 9x plus 3 times x minus 1 equals 8. I'm going to go ahead and get this in ax squared plus bx plus c form, and the first thing I'm going to have to do is FOIL. So I have 9x squared minus 9x plus 3x minus 3 equals 8. So I have 9x squared minus 6x minus 3 equals 8. I subtract 8 from both sides. 9x squared minus 6x minus 11 equals 0. Okay, now I'm going to go ahead and label my ABCs. X equals plus or minus the square root, negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 9 times negative 11 all over 2 times 9. So x equals 6 plus or minus 36 plus, sorry, the square root of 36 plus 396 all over 18. So x equals 6 plus or minus the square root of 432 all over 18. So I need to simplify 432. Well, that's going to factor into a 2 and a 216, 2 and 108, 2 and 54. That's going to factor into a 2 and a 27, which factors into 3 3s. So I group things by their squares. So I've got 2 squared times 2 squared times 3 squared times 3. If I was to take the square root of this, I would get 2 times 2 times 3, square root of 3, so 12 square root of 3. So x equals 6 plus or minus the 12 square root of 3 over 18. All these have a factor of 6, so x equals 1 plus 2 square root of 3 over 3. Plus or minus. So my final x's are 1 plus 2 square root of 3 over 3 and 1 minus 2 square root of 3 over 3. The next thing I want us to talk about is the discriminant. So the discriminant of a quadratic equation, ax squared plus bx plus c equals 0, is b squared minus 4ac. That's what's under the square root when we have our quadratic equation. This is the discriminant. And when you can use the discriminant to determine the number of solutions and the type of the solutions that a polynomial will have. So for example, if b squared minus 4ac is positive in a perfect square, so let's say it like added to like 16, right? Then you're going to have 2 rational solutions. If your discriminant is positive, but not a perfect square, so for example, 5, right? You're going to have 2 irrational solutions. If your discriminant is 0, you're going to have 1 rational solution. Let's see why that is. So if I had negative b plus or minus the square root of 0 over 2a, that gives me negative b over 2a, right? It gets rid of this plus or minus part, so there's only one possible answer. If b squared minus 4ac is negative, we will have 2 non-real complex solutions. Remember, when we take the square root of like a negative number, right, we can't do that, so it becomes I square root of 5, or if I had the square root of negative 4, that become 2i. So we can go ahead and determine the type of solutions by looking at b squared minus 4ac. So for problem 1, I have a is 6, b is negative 1, c is negative 15. So I have negative 1 squared minus 4 times 6 times negative 15. So that gives me 1 plus 360, I think. It is 360 section 361. That means I'm going to have 2 irrational solutions. Let's say I have 3x minus 4x equals 5. The first thing I need to do is get this in ax squared plus bx plus c form. So now I have a is 3, b is negative 4, and c is negative 5. So if I have negative 4 squared minus 4 times 3 times 5, that's going to give me negative 5. It's a negative. That's going to give me 16 plus 60, which is 76. So again, I would have 2 irrational solutions. Friendly reminder, we are skipping section 8.4 because I want to focus mostly on graphing our parabolas.